To get the approximate areas, of course, we could divide this up into any number of trapezoids and get those areas, right? So we could look at it this way. Okay, we got this, we got this, we got this, we got this. We're going to have a set of trapezoids for the top region. Now, where did all my chalk go? Yeah, right over here by the camera. Okay. And I do want to use different colors. Okay, so we're going to have trapezoids here, 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 here. Say if we do 4 trapezoids, and they should be more equal in width, but you get the idea, right? And we could add those up, and we're going to come up with something that's not too much different than 11 for the total area. Okay, if we did 2 trapezoids, I believe we'd come out with 11. If we did 2 trapezoids on the x squared graph, I believe we'd come out with about 2.4. And you can check me on that. It's always fun to find me wrong, and not at all rare. Okay. This one looks almost level. So again, I didn't have a really good picture, but we can find all these areas, right? Okay. Now the actual area is integral from 0 to 2 of x squared plus 4 dx. That's going to be x cubed over 3 plus 4x, evaluated between 0 and 2. And that's going to be what? 8/3 plus 8. 8 is 24/3. That's going to be 32/3, which is 10 2/3 as opposed to the 11 that I estimated from the trapezoids, right? And because this curve is concave up, the trapezoids run a little higher than the curve. So you would expect the trapezoidal approximation to be a little high, especially if we just do 1 trapezoid, okay? If we did the 2 trapezoids, we'd probably end up pretty close to 10.7, and this is 10.67, okay? And then this integral, 0 to 2, the square root of 2x dx is square root of 2 times, I'll do it this way, square root of 2 over 2 times 1 over the square root of x. Hopefully I wrote that down correctly. Let me double check. And that's going to be, yep, that's right. Okay. If it isn't, we'll find out in a minute. And you've got a problem because your antiderivative is undefined here. But you still clearly have an area. Okay? So actually, I hadn't intended this to be an indefinite integral, but we're going to have to do indefinite integrals anyway, so I'm going to do it. So I'm going to say, well, let's cross this step out here because this is undefined when x equals 0. Okay? And you know what I just did? Totally ignorant and stupid. I did a derivative rather than antiderivative because I wasn't seeing how that was going to come out finite. Okay? So I wrote that down very carelessly, so let's cross that out with a lot of attitude. So nobody can read this and verify what's obvious from the video. But I screwed it up. Okay? Okay, it's the square root of 2 times an antiderivative of the square root of x. Your simplest antiderivative being 2/3 x to the 3/2. Okay? And that's evaluated between 0 and 2. And that starts to make sense. Okay? I've seen you guys make that mistake too, but I didn't catch it from you. I probably originated it. Okay. And I actually haven't seen people making mistakes recently. Okay, so yeah, and we can check that. You know, derivative of x to the 3/2 is 3/2 x to the 1/2. Multiply that by 2/3, you get x to the 1/2, which is square root of x. And I factored out the square root of 2 because I didn't want to mess with that. Okay, well then, when x is 2, x to the 3/2 is 2.828, because it's going to be 2 times x to the 1/2. Okay? So we're getting 2.828. I said we were going to get something like 2.4. 2/3 of the square root of 2 is about 1. Seems like I was a little low. Of course, the curve does go above the trapezoids. So, yeah, that's entirely possible. Trapezoidal approximation should have been about 2.4. Okay, so when we do this, we get about 2.8 from this. Okay, 2/3 of the square root of 2 is 2/3, well, 2/3 of 1.5 is 1. 2/3 of 1.414 is going to be about 0.96. So 0.96 times 2.84%, it's down about 1. So that's pretty close to 2.7. That's consistent with the trapezoidal estimate I made based on 2 trapezoids. Okay? And we're going to go ahead and do this in decimals. And I'm just going to approximate this as 10.7. Okay? So now my question is, what are we going to do to find the area between the 2 curves? Hey, Robert.
I don't know whether you'd be busy or not, but trying to find you when you're not busy is like
That's okay.
trying to